Okay.
All right, hi guys, good afternoon. So day one, I used Google Meet for our video. I thought the quality wasn't that great, the picture wasn't that great. So day two, I tried to just use the camera on my computer, but then the file was really large, which meant it took me a long time to upload it and took you a long time to download it. This is Keegan, he's my helper today. Say hello.
Hi.
All right, back up. So today I'm going to try to use YouTube and see if that is better, because now I can use my tablet, which has much better picture quality. So day by day we'll figure this out. All right, figure out a system that works for us all. All right, so what we're doing today is a review of 9.4.9.5. I will post a blank copy of this review along with my answer key on Google Classroom. I'm going to do the odds with you here. I'll leave the evens for you to try on your own. That way you can try them and check the answers to make sure you're correct. Also look for an assignment on Google Classroom through your online textbook. Okay, so you will be doing that as well for a grade. And then we are supposed to have a quiz on this material. I'm still trying to figure out a way for me to assess you, probably through the online textbook, but I'm still trying to figure that out. So just stay, we'll figure it out, and I will let you know through Google Classroom what we're doing. All right, keep the emails coming with questions and with your feedback of what videos are the best and issues that you're having, so that we can try to make this work for us all. All right, so the first page of the review is just information about the two sections. So we have SOHCAHTOA, and then I'm going to talk about angle of elevation, angle of depression. It's all related to SOHCAHTOA, but these are just your word problems, okay? So we're going to start with the very first problem. Keegan?
What?
Okay, so the very first problem, we have this triangle. That picture is much better. So we have triangle STR with sides 10, 24, and 26. And the directions ask you to find the sine, cosine, and tangent of both acute angles, and leave your answer in both simplified fraction form and in decimal form rounded to 4 decimal places. So you should have a total of 6 answers, 6 equations, okay? So we're going to pick one of the acute angles to work with at a time. All right, so just like we did yesterday, I'm going to put an arc on that angle and then label the sides. This is my opposite. It's opposite of the acute angle S. This one is my adjacent side, and this one is my hypotenuse. Okay, so then I'm going to set up my 3 trait ratios for sine, or for angle S. So I have sine of angle S, cosine of angle S, and tan of angle S. Now, don't forget, we have that mnemonic device to help us remember how to set up the ratios. I'm going to write that on the top, and I recommend you write it on the top of all of your papers as well. So we use SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tan, opposite over adjacent. Okay? So, for sine of angle S, sine again is opposite over hypotenuse. Opposite over hypotenuse, 10 over 26. I'll go back through and simplify in a minute, okay? Cosine is adjacent over hypotenuse. So adjacent over hypotenuse is 24 over 26. And then finally, tan, opposite over adjacent, so that's 10 over 24. Okay? And then we'll go through. We're going to simplify all of the fractions and get decimals. All right, so 10 over 26 is 5 over 13, which rounded, you just divide 5 over 13 to get 0.3846. All right, and then 24 over 26 simplifies to 12 over 13. And again, as a decimal, that simplifies to 0.9231. And then 10 over 24 simplifies to 5 over 12. Just do the division to get the decimal approximation, 0.416 repeating. So those would be the 3 answers for the first acute angle. And then we have to do the exact same thing for the other acute angle, but since we have angle R, stand over there please. since we're going to be looking at angle R, that means that your opposite and your adjacent side are going to change. Okay? I'm going to kick you outside if you don't believe yourself. All right, so now we're looking at angle R. Opposite is this side, adjacent is that side. So you can see those two flipped, okay? Because across, that's your opposite, next to that's adjacent. Hypotenuse never changes. So then I'm going to have the sine of angle R, the cosine of angle R, and tan of angle R. Okay? So sine, opposite over hypotenuse. So opposite over hypotenuse, 24 over 26. Then cosine of R. So cosine is adjacent over hypotenuse, 10 over 26. And then tan of angle R, tan is opposite over adjacent, so 24 over 10. You're going to simplify each fraction and get the decimal approximation. All right, so you're going to have 12 over 13, which is approximately 0.9231. Then 10 over 26 is 5 over 13, which is approximately 0.3846. And then finally, the last one is 12 over 5, which is equal to 2.4. So those are the sine, cosine, and tangent ratios of the two acute angles for the first triangle. Thank you.
I want to erase.
You can erase at the end. I want to get through my lesson. All right, we're going to move on to problem number 3. Thank you. So for problem 3, the directions for problems 3, 5, and 6 say, find the value of the variable and round the answers to the nearest tenth. Okay, so for problem 3, our diagram looks like this. That's my bad right angle. This angle is 40 degrees. This is 15. This is x. So whatever acute angle is given, that's what I'm going to focus on, and I'm going to name the sides of the triangle based on that acute angle. So this is the acute angle. This is my opposite side. This is my adjacent side. And the hypotenuse is always the one across from the right angle. So now I have to pick which trig ratio I'm going to use based on what I'm trying to solve for and what I know. I know the opposite. I'm trying to find adjacent. So I ask myself, which trig ratio deals with opposite and adjacent? So I scan opposite, adjacent, that's tan. So I'm going to write tan, and then it's always of the acute angle, tan 40, is equal to opposite over adjacent, 15 over x. Okay? Once you have it set up, you have to isolate the variable before you pick up your calculator. So to isolate the variable, I'm going to multiply both sides by x to get x out of the denominator. So I have x times tan 40 equals 15. To get x by itself, the inverse operation is division. So I'm going to divide both sides by tan 40. And now I have x is equal to 15 over tan 40. Once my variable is isolated, I'm going to pick up my calculator. Grab my calculator. If it's not in degree mode, sorry guys, if it's not in degree mode, make sure you put it in degree mode. Okay, so in my calculator, I'm going to do alpha y equals to get a fraction. And then I'm going to do 15 over tan 40 so that my calculator matches my paper. All right, and then the directions say to round all answers to the nearest tenth, so that's one decimal place, so it's going to be 17.9 as my answer.
Should I erase that?
No, thank you. So x is approximately 17.9. Okay. And thank you, Keegan. All right, moves inside. Moves inside. All right, let's move on to problem number 5.
I put a little back.
Thank you. Okay, so for problem number 5, let me draw this diagram.
Mom, can I draw this?
Not right now, Beth. Okay, so here's my right angle. This side is 36, this is x, and this is 43. So again, look at that acute angle that's given and label the sides of the triangle opposite, adjacent, hypotenuse. So the one across is my opposite. The one next to is adjacent. And the one across from the 90 is my hypotenuse. Okay, so thank you. Okay, so I'm looking for my adjacent. I know my opposite. So again, scan which one deals with opposite and adjacent. It's tan. So it's going to be tan of the angle, tan of 43, equals opposite over adjacent, 36 over x. This one's actually pretty much the same as the last problem. Setup's the same, solving's going to be the same. So I'm going to multiply both sides by the denominator, which in this case is the variable. So I have x times tan of 43 equals 36. The opposite of multiplication is division, so I'm going to divide both sides by tan 43. So now I have x is equal to 36 divided by tan 43. Okay, so then I'm going to take my calculator. Now I'm going to type that in. And instead of using the fraction button now, I'll just use the division button to show you don't have to use the fraction button. So 36 divided by tan, what is it again? 43. And I will close the parenthesis. If I push enter, round to one decimal place, so that's 38.6. So x is approximately 38.6. Okay. So that is problem number 5. All right, we're going to move on to problem number 7. All right, so for problem 7, let me draw the diagram. We have 117, 20 degrees, R and S. So we have 2 unknowns in this problem, so I'm going to have 2 different problems to set up. Okay, so if this is my acute angle that I'm working with, then my opposite, the one across, my adjacent, the one next to, and the hypotenuse is always across from the right angle. All right, so focus on one variable at a time. So maybe cover up the S. Let's say, pretend that that's not there. All right, I know my adjacent. I'm trying to solve for hypotenuse. So which one is adjacent hypotenuse? That's cosine. So it's going to be cosine of the angle equals adjacent over hypotenuse. So cosine of the angle equals adjacent over hypotenuse. Okay. Now I'm going to set up the other equation as well, then we'll go through and solve both of them. So if I'm trying to solve for S and I know 117, right, you're always going to use the one side that you know and then the one side you're trying to find. So adjacent and opposite again is tan. So tan of the angle, tan of 20, is equal to opposite over adjacent. So it's S over 117. All right, so notice that the variable's in the denominator here, it's in the numerator there. So the math is going to be a little bit different for both equations. For the first one, I'm going to have to multiply by whatever's in the denominator. In this case, it's R, which is what we saw in the last 2 examples as well. So I have R times cosine 20 is equal to 117. To get R by itself, I'm going to divide by cosine 20. So now I have R is equal to 117 divided by cosine 20. Okay. Now I'm going to pick up my calculator, type that in. 117 divided by cosine 20. Or you can use a fraction bar as well. And you should get 125.5, or 124.5 is what the calculator says. So R is approximately 124.5. And in terms of this problem, if they're saying this side is 117, it makes sense for that side to be 124.5 units long. Okay. for the next one, again, like I said, the math's going to be a little bit different. This time the variable's in the numerator, so I just multiply both sides by 117. So these problems where the variable's in the numerator are a little bit easier because after one step the variable is by itself. S is equal to 117 times tan 20. One last step that I have to do for that problem. So take your calculator and type in 117 times tan 20, and you get 42.6 approximately. Okay, so S is approximately 42.6 units long. Okay. Again, I think I pointed to the wrong side. R being the hypotenuse, it makes sense that is the longest side. Okay, and then S is much shorter. All right, so that was problem 5. We'll move on to the next page.
Yes.
So problem 9.
So let me check in on it. I mean, I did look the other day and all looked good on my end. The only thing that I can really think of, is still almost
Okay, so for this example, a few things to notice. First off, this triangle happens to be a 45, 45, 90 right triangle, right? If this angle is 90, this one has to be 90 as well. If that angle's 45, this one has to be 45 as well. So you don't always have to use trigonometry. For some of these problems, you're going to be able to use special right triangle information. Also, Pythagorean theorem can be used as well, okay? So if it's a 45, 45, 90, hopefully you remember that the legs are congruent, so I already know that x is equal to 82. I didn't have to do any work, just recognizing 45, 45, 90. It's an isosceles right triangle. My legs are congruent. All right, so I can even label that in my diagram now if I want, because maybe that'll help me solve for y. Okay, so for y, it's not a special right triangle, right? It's a 28-degree angle. Now I can use trigonometry, okay? Here is my opposite side, OPP. That's 82 now. I'm looking for my adjacent side. So I have to remind myself, opposite adjacent, that's tan, right? So it's going to be tan of the angle, tan of 28, is equal to opposite over adjacent, 82 over y. Keep in mind as well, if I had tried to set up this trig ratio first, I would have had two unknowns. I would have had the x and the y. So you can set it up, but then you have to go figure out how to solve for the x or the y and then go back. Okay? So multiply both sides by y. So you have y times tan 28 is equal to 82. Divide both sides by tan 28. So y is equal to 82 divided by tan 28. Okay? So take your calculator. 82 divided by tan 28. And you can see the answer of 154.2. That was problem number 9. So even though it looked a lot more challenging, because it was 3 triangles basically, big, small, medium, it really wasn't that bad of a problem. When you break it down, just look at one triangle at a time. All right. Problem number 11. You have a right angle, M, and 50, and here's 72. Okay, so again, 2